Hello dear students, in this video we are going to discuss about the Stokes theorem. Again, Stokes theorem is defined on the surface integral. So let us take the first statement. If S be the open surface bounded by closed curve C and Fr be the continuous and differentiable vector function, then closed integral Fr into dr bar, or we can say this is the circulation, it will be same as double integration over the surface S lambda cross Fr cross. It means that this is what curl of a vector field Fr dot n cap ds, where n cap is the unit outward normal at any point of the surface S. And if you are given that any surface, so from this you can find out unit normal vector n cap equal to grade phi divided by its length. So let us see the first example. Verify Stokes theorem for Fy 4xi minus 4xj plus 3k, where S is a disk of 1 unit radius lying on the plane z is equal to 1 and C is its boundary. So here C is its boundary. This is our plane. If I say this is z equal to 1. So this is a circle x square plus y square equal to 1. Now by Stokes theorem, here we want to verify Stokes theorem. So this is our Stokes theorem that you can see, where S is the surface of the disk of 1 unit radius lying on the plane z is equal to 1 and C is the circle x square plus y square equal to 1. So for that, first we have to find out curl of Fy. So this is what curl of vector field Fy. That is what lambda cross Fy. So this is as a determinant I Z K del by del x del by del y del by del z. This is F1, this is 4y minus 4x and 3. After finding this determinant, we can evaluate this one, that is the minus 8k. Since disk lines on the plane z equal to 1 and which is parallel to xy plane, that you can see that this is our xy plane and this is parallel to z is equal to 1 plane. So n cap, therefore n cap is equal, that is the k cap. Now just take the projection of the disk in the xy plane and that is what exactly you can easily verify that x square plus y square equal to 1. So in that case, ds will be what? Dx divided by mod of n cap dot k cap equal to, that is dx divided. Because of n cap is what? That is the k cap and k cap itself is that. So k dot k, so it will be only 1. Now substituting all these value on the whatever we have the Stokes formula. So let us see that RHS. So this is your RHS of the Stokes theorem. So here we have obtained that this is the curl of vector field Fy. Curl of vector field Fy, whatever we have, this is the minus 8k. So we are substituting over here. N cap is, that is the k cap, and taking its dot product, we are getting that minus a double integration over the region R dx dy, where R is the region of the circle. So as we know that area of the circle, using that double integration is what? Double integration, that is the dA over the region R, and that is what? Pi r square, whatever we have that circle. So using this standard formula, minus 8 times area of the circle, but here radius is what? That is the 1. So you can notice from here. So therefore minus 8 pi r is equal, that is 1, so 1 whole square. After simplifying, you will get minus 8 pi. So that is the equation number 1. Here, C is the boundary of the disk, that is the circle x square plus y square equal to 1 and that is lying on the plane z is equal to 1. So we can find F bar dot dr bar, because what we want to find out? Now we want to find out line integral F bar dot dr bar. So here F bar is given and dr, that can be written as dxi plus dyj plus dzk. So taking the dot product of these respective two vectors, we will get 4y dx minus 4x dy plus 3 times dz. Since z is equal to 1, so we can write dz equal to 0. So in that case, we will obtain that this one term only and last term will be cancelled out because dz is 0. So therefore, our line integral becomes like this way. So now to evaluate this one, we are using the parameterization of the circle. We know that equation of the circle is what x square plus y square equal to 1, and based on that we can use that parameterization. X is equal cos theta, y is equal sin theta. So dx can be written as what minus sin theta dx, and dy can be written as cos theta d theta. And to get the circle, we have to rotate theta from 0 to 2 pi. So our single integration becomes integration that is 0 to 2 pi. This is our 4 times 1. So that is 4 sine theta into dx. So this is minus sine theta dx d theta minus 4x, and this is what, that is the dy. So just let us replace it, and you will get, after simplifying this one, and sin square theta plus cos square theta equal to 1, and that is what, integration with respect to theta, it is theta, but limit is that is from 0 to 2 pi, so it will be 2 pi, so you will get minus 8 pi. So from the equation number 1 and 2, you can notice that both have line integral as well as double integration, both have the same answer, that is the minus 8 pi. It means that Stokes theorem is valid. So whenever you're supposed to use Stokes theorem, so you should think about that the curve should be the closed curve. Now let us see the another example, and find the work done in the moving a particle once around the perimeter of the triangle with the vertices at this is 2, 0, 0 along the x-axis. This is along the y-axis, that is 0, 3, 0, and along the z-axis we have point, this is 0, 0, 6. And force field is also given. We want to find out work done, so this is the formula. By using Stokes theorem, we can use this one. So we have final work done is equal double integration name across fy dot n cap ds, and this is what curl of a vector field fy over the surface S. Now S is given by this one points, so we can write x divided by intersection of x axis, and plus y divided by coordinate of y axis, and plus z divided by coordinate on the z axis equal to 1. And after simplifying, you will get this one. Now you can find the curl of the vector field x1. And we have that surface phi is equal 3x plus 2y plus z. So you can find its unit normal vector. Now take the projection on the xy plane. So the surface region will be bounded by. So you can notice that this is x-axis and this is the y-axis. So along the x-axis, so your point is that is 2, 0, and this is the 0, 3. So this one line will be x divided by 2 plus y divided by 3 equal to 1. So you can notice that this is 3x plus 2y is equal to 6. So that is we have written over here. This is the line y is equal 0, and this is the line x is equal 0. So ds also you can find, it is very easy because we have assumed that projection on the xy plane. So limit also you can find. So first assume that the limit for y, so you have to take straight parallel to y-axis. So limit will be here, I have mentioned. And limit for x, so range is starting from x is equal 0 to x is equal to. So that for work done that you can find, and your answer will be that is the 21. Thank you.